Hello, my awesome Algebra 3 class. Today, we will apply the Pythagorean identity, and this is found in Chapter 7, Section 3 in our ebook. We're going to be looking at the signs of the trigonometric functions. The sign of a trigonometric function depends on the quadrant in which it lies. Remember, if the terminal side lies on an x or y axis, it's a quadrantal angle. We're talking about a terminal side that lands in or lies in the quadrant. So we're going to draw here an xy axis. Here's our quadrant 1. We're going from 0 radians to pi over 2 radians to pi radians to 3 pi over 2 radians to 2 pi radians, which is one complete rotation. In quadrant 1, all the trigonometric functions are positive. In quadrant 2, only the sine and its reciprocal cosecant are positive. So that means that the other 4 trig functions will have to be negative. Again, in quadrant 2, there are only 2 trig functions that are positive, sine and cosecant, and the other 4 trig functions will be negative. In quadrant 3, only tangent and its reciprocal function, cotangent, are positive, which means that the other 4 trig functions in quadrant 3 will be negative. So again, in quadrant 3, only tangent and its reciprocal function, cotangent, will be positive. In quadrant 4, only cosine and its reciprocal secant will be positive, which means that the other 4 trig functions will be negative in quadrant 4. So we have here a little saying that will help us remember this. A smart trig class. A smart trig class. All of the functions are positive in quadrant 1. In quadrant 2, just sine and its reciprocal function, cosecant, smart. T stands for tangent. In quadrant 3, only tangent and its reciprocal function will be positive. Then C, class, stands for cosine. Only cosine and its reciprocal function, quadrant 4, will be positive. So here we have a little saying, a smart trig class, to help us remember which trig functions are positive in which quadrants. Yesterday, we learned that for the unit circle, the equation is x squared plus y squared equals 1. We also learned that on a point on the unit circle, the x-coordinate is the cosine of the theta, and the y-coordinate is the sine of the theta. So we're going to substitute for x and y here. You see, cosine of theta squared plus sine squared of theta equals 1. A shortcut, instead of using the parentheses, we put this exponent 2 right here. So it's cosine squared of theta plus sine squared of theta equals 1. Now, this equation right here is known as the Pythagorean identity. It is one of 3 Pythagorean identities. We're using this one today. Cosine squared of theta plus sine squared of theta equals 1, and it's known as the Pythagorean identity. And you think about a right triangle. If you're in a unit circle, remember the radius is 1, and if you have this vertical side here being our y, which is sine of theta, the horizontal side being our x, which is cosine of theta, then you see we have again that Pythagorean identity, cosine squared of theta plus sine squared of theta equals 1. So we're going to look at an example where we're going to use that identity. It says if sine of theta is equal to 3 over 7 and theta is in quadrant 2. Now remember, in quadrant 2, there are only 2 trig functions that are positive, sine and its reciprocal cosecant, so this is a positive. We're going to find again the cosine of theta. So if sine of theta equals 3 over 7 and the theta is in quadrant 2, find the cosine of theta. We're going to substitute the known value for sine into the Pythagorean identity. So let's look at that. Here's our Pythagorean identity. And we have here cosine squared of theta is equal plus 3 over 7 squared, because remember the sine of theta was 3 over 7, so we have to square it. And 3 squared is 9, 7 squared is 49. We subtract 9 over 49 from each side, and we make 49 over 49, because in order to add or subtract fractions, we need what? The like denominator. And then 49 minus 9 is 40, so we have cosine squared of theta is equal to 40 over 49. But remember, we're looking for the cosine of theta. So what we're going to do, we're going to take the square root of the cosine squared of theta, which will be equal to the square root of 40 over 49. When we take the square root of something that is already square, we're going to get plus or minus. So the cosine of theta equals plus or minus the square root of 4 times 10, trying to simplify the numerator and denominator. The square root of 49 is 7. Well, the square root of 4 times 10 becomes the square root of 4 times the square root of 10. The square root of 4 is 2. 10 cannot be simplified anymore, and we have a 7 in the denominator. So cosine of theta is equal to plus or minus 2 times the square root of 10 over 7. But the thing is this going to be a positive 2 times the square root of 10 over 7, or it's going to be a negative 2 times the square root of 10 over 7? We have to remember that because we are in quadrant 2, there are only 2 trig functions that are positive, sine and its reciprocal cosecant. But we have a cosine. Remember, all the other 4 trig functions will be negative. So in quadrant 2, cosine is negative. So our cosine of theta will be equal to the negative 2 times the square root of 7. Excuse me, negative 2 times the square root of 10 all over 7. So again, you have to make sure you know which quadrant you're in and which trig functions are positive in which quadrants. And as you are reviewing this video, remember to stop, rewind, review. Stop, rewind, review until you understand everything that is being said in the video. My love goes out to you.